Welcome to the SPSS tutorial for a one-way between groups ANOVA. This is Dr. Zako. In this tutorial, you will learn how to conduct a one-way between groups ANOVA in SPSS and use SPSS output to write an APA results section. In this tutorial, we will consider the following research question. Is there a difference in high school students' level of satisfaction with school based on their family's socioeconomic status? Accordingly, the null hypothesis in which we will be testing is, there is no difference in high school students' level of satisfaction with school based on their family's socioeconomic status. Considering both the research question and the null hypothesis, you will note that the independent variable is family socioeconomic status. This has three levels: upper class, middle class, and lower class. The dependent variable is level of satisfaction with school. Since we have one dependent variable that is continuous and an independent variable with three levels, a one-way between groups ANOVA is a good choice to analyze our data. For a one-way between groups ANOVA is used when you have one dependent continuous variable and one independent variable with three or more groups or three or more levels. In the term one-way between groups ANOVA, one way indicates that there's only one independent variable. The between groups part means that you have different subjects or different cases in each group. In order to answer the research question and test the null hypothesis, we need to locate the data set associated with this question. In IBM SPSS, open the data set which you desire to work with. Here we're going to use the one-way ANOVA practice data set. Once you have the data set open, from the menu at the top of the screen, click Analyze, then Compare Means, then on One-Way ANOVA to conduct a one-way ANOVA. Click the One-Way ANOVA button to progress in this tutorial. The One-Way ANOVA dialog box will appear. First, click on your dependent variable or continuous variable. Here we select School Satisfaction. To the dependent variable, move the variable into the box marked Dependent List by clicking the arrow button next to this box. Click the arrow button to progress in this tutorial. Now click on the categorical or independent variable. Here we click on SES level. Click the arrow button next to the factor box in order to move this independent variable into that box. Click the arrow button to progress in this tutorial. Once the dependent variable has been moved into the dependent list box and the independent variable has been moved into the factor box, click the Options button. The One-Way ANOVA Options dialog box will appear. Here you want to click on Descriptive, Homogeneity of Variance Test, Browns-Forthworth, Welsh, and Means Plot. For the missing values, make sure there is a dot in the option marked Exclude Cases Analyze by Analyze. Then we click the Continue button. Click the Continue button to progress in this tutorial. This will take you back to the One-Way ANOVA dialog box. Now click on Post Hoc. ANOVA Post Hoc Multiple Comparisons dialog box will appear. Here you want to click Tukey, as well as make sure that your significance level is set at 0.05, unless you want to set a more stringent significant level such as a 0.01. Please click Tukey to progress in this tutorial. Then click OK to go back to the One-Way ANOVA dialog box. Then click the OK button to generate your SPSS output. When the SPSS output is generated, the first step that you want to take is to check the sample information and note the descriptive statistics. This can be done in the descriptives table. First, note, what is the N? Are the N's for each group correct? Next, note the descriptive statistics that you will need to report in your APA results section. For example, for the lower class, you will note that the mean satisfaction score is 21.36. The standard deviation is 4.55, and the N is 147. You can also note this descriptive statistics for the middle class as well as the upper class as well as the pooled means. In order to progress in this tutorial, click the n value, the total n value. We want to assess the homogeneity of variance assumption by looking at the test of homogeneity of variance table. This tests whether or not the variance in the scores is the same for each of the three groups in which we are looking at. You want to check the significance value, the SIG, for the Levine's test. If the number is greater than 0.05, you have not violated the assumption of homogeneity of variance. In this example, the SIG is 0.475. Since this is greater than 0.05, we can conclude that we have not violated the assumption of homogeneity of variance, that is, the assumption is tenable. If you find that you have violated this assumption, that is, that you have a significance value of less than 0.05, you will need to consult or look at the table called Robust Test of Equality of Means. The two tests shown in this table are preferable whenever you do violate the assumption of the homogeneity of variance. When you are finished examining this output, to progress in this tutorial, click the correct way to report the homogeneity of variance assumption in an APA results section. The third step that we want to take is to assess the significance level of the ANOVA. Since the assumption of homogeneity of variance was tenable, we look at the ANOVA table. If it was not tenable, we would then look at the robust test of equality of means. Let's take a closer look at the ANOVA table. The primary item in which we're interested in this table is the columns marked SIG, S-I-G. This is the significance value. If the significance value is less than or equal to 0.05, there is a significant difference somewhere among our means on our dependent variable in our three groups. Note that this, however, does not tell us which group is different from which other group. The statistical significance of the difference between each pair of groups is provided in the table marked multiple comparisons. This table gives us the results of our post hoc tests, which we will look at next. We will also need to look at the descriptive table again to look for the means of each group. However, note that in this example, our overall significant value is 0.01, which is less than 0.05, thus indicating that we have a statistically significant result somewhere in our groups. In order to progress in this tutorial, look at the options for reporting the ANOVA. Select the correct option for reporting the ANOVA in an APA results section. This will let you progress to the next slide. Since our overall ANOVA was significant, the fourth step that we take is to evaluate the multiple comparisons. We do this by looking at the multiple comparisons table. Remember, we don't need to look at this table if we did not have a significant overall ANOVA. In this table, the post hoc tests are listed. This will tell you exactly where the difference among the groups occurred. Look at the column labeled mean difference. Do you see any asterisks? We do here. If you see an asterisk, this means that the two groups being compared are statistically significantly different from one another at an alpha level of 0.05. The exact significance value is seen in the column labeled SIG. Here we look at the results and we note that the lower class and the upper class groups are statistically significantly different from one another. However, we note that there are no asterisks in the middle column. However, when we look at both the mean difference column as well as the significance column, we note that the middle class group does not statistically significantly differ from the lower class or the upper class. Roll your mouse over the significance column to see how you can report this information in an APA results section. When you are finished looking at or evaluating this data, please click the mean difference column to progress in this tutorial. Now that we have determined that there was a significant difference among our groups, and we determined where that significant difference was between our groups, our next step is to compare the mean scores between the groups. An easy way to compare the mean scores between our different groups is to use the mean plots. As you scroll down to the very bottom of your SPSS output, you will find this plot. Looking at this plot, you can see that our students from our low socioeconomic families had the lowest satisfaction with school, whereas our students that come from our families with higher socioeconomic levels had the highest satisfaction with school. Note that these plots can be misleading. Depending on the scale used on the y-axis, even small difference can look very, very dramatic. Therefore, whenever you are comparing the means, it's also important to look back up at the descriptives table and look at the actual difference between the means. You also need to compute the effect size. To compute the effect size, you will need to use the data in the ANOVA table. The formula for eta squared is sum of the squares between groups divided by the total sum of squares. It's interpreted based on Cohen. Roll over the sum of squares column to see the effect size for this data set. Then to progress, click the correct interpretation of this effect size. Now that we have reviewed and discussed the SPSS output for a one-way between groups ANOVA, we can use this output to write an APA results section. One example is provided for you here. Read through the next two slides. When you're finished with the slide, click anywhere on the slide to progress. Thank you for taking the time to complete this SPSS tutorial for the one-way between groups ANOVA. You should now know how to conduct a one-way between groups ANOVA using SPSS and use the SPSS output to write an APA results section.